Let's take a minute to analyse this hydrogen NMR spectrum. First of all, I can see that there's 3 hydrogen environments because there's 3 distinct peaks here. Let's have a look at each peak and work out what information can be gained from those. First things first, I've got these numbers here which tell me about the size of the peak or the integration. This tells me about how many hydrogens are in this particular environment. In this one, there are 2 hydrogen environments. What that generally means, it will probably be a CH2. This is a 1 hydrogen in that environment, so therefore it's either going to be a CH or it could be a hydroxide or a O to H bond there. So therefore both of these would have an integration of 1, showing the fact that there are only 1 hydrogen in that environment. This one here has got an integration of 3, so therefore it's most likely going to be a CH3. So that's the first thing you get from the second thing you get from your information in your spectrum. You get, first of all, how many environments there are, which is 3, and how many hydrogens are in that environment by the size. The next bit of information is about the splitting, which tells us about the neighbours, which is next to the environment. So this way is split into 4, and we have the n-1 rule. What that means is that he is going to have 3 hydrogens next to him, which suggests he's going to be next to a CH3. This guy here either means that it's going to be a carbon, a hydrogen bonded to something without hydrogens, or it's going to be a hydroxyl. So therefore, I'm going to assume it's going to be a hydroxyl there. This guy here has been split into 3, so therefore he is neighbours with a CH2. The last piece of information I'm going to take from this is looking at the chemical shifts, which is about the types of environments. Now, our data booklet here has a whole bunch of types of environments. I'm going to start off with this peak here. It's really low in our chemical shift. What that means is if I go to here, it's going to be a pretty boring alkyl group. It's going to be a CH bonded to something that's not that exciting at all. If that kind of makes sense, it's going to be this CH3 bonded to just simply a CH2 there. This guy here has got 1, so it's like, because I think it's an OH, I reckon it's going to be anywhere within this section here. I can see the OH here, which is, where is it here? That is anywhere between 1 and 6, so that's not going to give me much information at all. This one up here, which is just above the 3.5, I'll have a look at what information I have here about 3.5, and it sits here. It's either going to be a hydrogen bonded to something like an ether group here, but this guy here, which is an OH, which I think it has as well, sits in there as well. So chances are this guy here is going to be also bonded to an O to H. What that means is I put all this together and come up with a structure which kind of makes sense. So let's start off with my edge pieces, which is a CH3. That is going to be bonded to a CH2, and I'm going to have an OH there somewhere, which kind of makes sense, and it's going to sit here. And that's how I've analysed this spectrum to come up with this structure.